All right, so in this video, we want to do the curve sketching algorithm for this equation over here. So the first thing we want to do is we want to derive the equation. So that's going to be 4x cubed minus 8x. Then we need to make it equal to 0, and we need to factor this. So if I make it 0 over here, I could common factor out a 4x. I'm left with x squared minus 2. So over here, I'm going to find my critical points now. My first critical point is x equals to 0. And over here, my critical points are basically x equals to plus or minus square root 2. Because if I move the 2 to the other side, it becomes positive 2. And when I square root, I have 2 points created with a square root. So these are my critical points right here. I'm going to put them on my number line to classify them and then find my intervals of increase and decrease. The lowest one is negative root 2. Then I have 0. Then I have positive root 2. So I'll start by testing this range over here. I'll start with f prime of negative 2 because negative 2 is smaller than this. I'm going to sub this in my derived equation here. I'll do this in my calculator. 4 times negative 2 cubed minus 8 times negative 2 is negative 16. So this is a negative value. It means it's decreasing. So I'm going to draw an arrow going downwards. Then I'll pick a value between these two. I'll pick positive 1. I sub it in this equation. Do that in my calculator. I get negative 4. Oops, I put in the value for that one by accident. 1 is between 0 and positive root 2. So I accidentally did this range first. For this range, I'll test negative 1. And if I do this in my calculator, I will get positive 4, which means it's increasing here because it's a positive value. And for the last range, I'll test positive 2. I think I'll probably just end up with positive 16 or some kind of positive value. Yep, positive 16. If I put in my calculator, since it's a positive value, it's increasing. So we can tell that we have 2 minimums over here and 1 maximum. So let's start with the minimum over there. The first minimum has an x value of negative root 2. I'm going to sub this into my original equation to find the y value. And I get a value of y value of negative 1. Again, if I sub this in the original equation. I'll do the other minimum next, which is positive root 2. And if I sub this in the original equation, I will also get negative 1 over here. So I found my 2 minimums. I'll do my maximum next. My maximum has an x value of 0. If I sub this in the original equation, I will get a y value of 3. That's also the same as my y-intercept in this question, just something to note. Then I will do my intervals of increase and decrease. My intervals of increase are from negative root 2 till 0. And then from positive root 2 till infinity. My intervals of decrease are from negative infinity to negative root 2. And then also from 0 to positive root 2. I'll do my second derivation next to find my inflection points. So f double prime x equals 12x squared minus 8. I'll make this equal to 0 and solve it. 12x squared minus 8. So this, you can just move to the other side, even though it's quadratic. You can still solve it like a linear equation. Divide by 12, divide by 12. So this is just 3 over 4. No, is that 2 over 3? 2 over 3 equals x squared. And if I square root both sides, I'll get plus or minus 2 root 2 over 3 equals to x. That cannot be simplified. Basically, you can just leave it like that. And then find the y value. So my inflection point has an x value of negative root 2 over 3. And then it's going to have a second inflection point with positive root 2 over 3. And then I just have to find the y values of these. So I'll sub these in the original equation in my calculator. And I get 175 over 81. Or if you had to do the decimal value, it would be 2.16. And I get the exact same for this one over here as well. It's 175 over 81. So now that I found my inflection points, I can do my intervals of concave up and concave down. Oops. I'm going to draw my number line for that. I'm going to put my inflection points on the number line. So negative root 2 over 3. And here positive root 2 over 3. I'm going to test all my three ranges. I'll pick a number out here. I'll just pick -1. So f double prime of -1. If I sub in -1 into this equation over here, I'll get positive 4. So if it's positive, it means the interval is concave up. In between these two, I'll pick a 0. 0 minus 8 is just 0, -8. Negative value means it's concave down. Then between these two, I'll pick positive 1. So f double prime of positive 1 is also 4, which means this is going to be concave up. So my intervals of concave up are negative infinity to negative root 2 over 3, and also root 2 over 3 to positive infinity. My intervals of concave down are just negative root 2 over 3 to positive root 2 over 3. The last thing I'm going to do is I'm going to sketch this function out. I'll put all my points. So my mins are negative root 2 and 1, and positive root 2 and 1. My max is 0 and 3. My inflection points are negative root 2 over 3 and 175 over 81. So if you convert these to decimals, they'll be a bit easier to plot, but we can tell that they are approximately somewhere over here in between these, slightly more towards the positive because they are positive values on the y-axis. And then I'm just going to draw it. So this is concave up. And then this is concave. Oops, just realized I was in the camera. This is concave down. And then this is concave up. And then once I have all my drawing done, I'll label all my points. So max is 0 and 3. Mins are negative root 2 and -1, and positive root 2 and -1. And inflection points are root 2 over 3 and 175 over 81, and this one's negative root 2 over 3 and positive 175 over 81.